This video is for Math 112, and this is for section 4.1. This is the last chapter in the textbook, chapter 4, and this one is going to cover the law of sines and the law of cosines. So section 4.1 is about the law of sines. 4.2 is as well, and we'll talk about that in another video. So first of all, let's talk about what does the law of sines say, where does it come from, how do we know that it's true? Okay. So, the law of sines says that the ratio of the sine of an angle to the side across from it is the same for all the angles and sides. Okay? So in other words, sine of A over the sine of A is the same as the ratio of the sine of B to the side of B, and that's also the same as the sine of C to the side of C. So one thing that's important about the law of sines and the law of cosines is that they don't have to be used in right triangles. Okay? A lot of what we've done up to this point has been focused on right triangle trigonometry. We introduced the unit circle trigonometry and all of the graphing that goes along with that. So now we're going to talk about, well, what if we have a triangle that's not a right triangle? We can fall back on the law of sines and the law of cosines in these situations. So let's talk about the notation. So this is a standard notation that's used in trigonometry where the side is identified by a lowercase letter and the angle is identified by an uppercase letter. So I'll use the same diagram that I've got in the textbook here. Let's see. Let's make that a little bit different. Okay. Make it clear that this is not an equilateral triangle. Okay. So there's angle A, angle B, and angle C. So this is side C is across from angle C, side A is across from angle A, and side B is across from angle B. So that's the standard notation that's typically used in trigonometry to identify sides and angles. Okay? So whenever you see this setup, this side has to be the side that's across from angle A. Okay? Otherwise, this statement won't be true. All right. Well, how do we know that it's true? All right. You may or may not have picked up on the fact that that is a favorite question of mine, and that is because I think it's fundamental to the nature of mathematics to question, how do we know that something is true? Okay. Well, a time-honored trick in mathematics is to fall back on something you already know is true. In this case, right triangle trigonometry. Okay? So we're going to drop a perpendicular through the angle C so that we create two 90-degree angles down here along the side AB and two right triangles. Let's say if I call this D, well, let's see, did I do that in the textbook? I didn't label that, so I'm not going to worry about it too much. In any event, we've got two triangles, ADC and BDC, and they're both right triangles. So, let's see, we can call this H because this is the height of the triangle. That's another important idea, is that the height of a triangle is not necessarily going to be one of its sides, okay? It's going to be the actual height that is perpendicular to its base. The height has to be perpendicular to the base, otherwise you're talking about something besides the height and base. Okay, well, if we know that, then let's see. If we've got this set up here, is what I'm saying, then we can say that the sine of B is equal to h over a, opposite over hypotenuse, okay? And we can say that the sine of a is h over b, okay? Again, opposite over hypotenuse. So that means that h is equal to a sine b, and down here, h is equal to b sine a, okay? Well, we can substitute in this expression for h because we know that it's equal to h. So now we can say a sine b equals b sine a. Then, on both sides, we divide by a times b, and there's one part of the law of sines, sine b over b equals sine a over a. And we can turn this triangle on its side, draw another perpendicular height there, and equate all of these ratios to each other. We can also do this for an obtuse triangle. Notice that I've drawn it so that all of these angles are less than 90 degrees. If you've got an obtuse angle in there, you can still set this up and prove that the law of sines will be true. Okay? All right. And that's typically how I try to present things. Is I try to give a basic explanation of where this is coming from without getting too tangled up in the details. The details are important to make sure that this works in all situations. But for our classroom purposes, I don't think that we need to go quite into that detail. Okay? All right. So there's the law of sines. This is where it comes from. And you can use it in either form. And I point this out in the textbook. So you can state it like this, or you can take all the reciprocals, because the ratios will still be equal to each other. And it depends on what kind of problem you're trying to solve. Often, if you put what you're trying to solve for in the numerator, it can make the algebra a little bit more straightforward. Okay? And so I have a tendency to do that. If I'm trying to solve for a side, I'll set it up like this. If I'm trying to solve for an angle, I'll usually set it up like this. All right, well, let's look at some problems then. These are on page 139. And let's see, the first 6 of them have pictures or diagrams to go along with them. And then the last ones don't. So let's start working our way through them here. Problem 2. So we've got a triangle like this, a 100-degree angle. We don't know what side A is. Angle C is up here. So that means that this is angle A, this is angle B. Side B is equal to 6, and angle B is 32 degrees. Okay, so let's see here. Angle A, angle B, angle C. Angle A is 100 degrees. Angle B is 32 degrees. They have to add up to be 180. And so if we do 180 minus 132, that should give us 48 degrees for C. Okay. All right. And now the sides. A, B, and C. Some of these I might change those to approximately equals to, because in B we know side B is 6, but we don't know side A and we don't know side C. All right, so let's go ahead and set these up. So A over the sine of angle A should be equal to B over the sine of angle B. All right, so really what we need to do here is multiply on both sides by the sine of 100. And let's see, make sure we're in degrees. Okay, so then we want to do 6 divided by the sine of 32, and then multiply that by the sine of 100, and that says that A should be approximately 11.5 Yeah, I think we're looking for the nearest hundredth on the sides. And in the next section, when we get to finding angles, we'll typically do that to the nearest tenth of a degree. Okay, and then to find side C, I would suggest using the exact information that we've been given in the problem rather than using this setup right here because this value is approximate. Why don't we use the exact values and we'll set that equal to C over the sine of 48 degrees. So we do that 6 divided by the sine of 32, but this time we multiply it by sine 48. So those cancel, and C then is going to be about 8.41. Okay. Now, there's something that's true in all triangles that you can use as a very quick check on your work, and that is the longest side is always across from the largest angle. Okay, you can see that that's true here, right? The biggest angle is 100 degrees, the biggest side 11.15, so that matches up. The shortest side is B, which is 6, and that matches up to the smallest angle, and that just gives us a little bit of confidence that we've done this problem correctly, and it's no guarantee that the answers are numerically correct, but at least it's a preliminary check on our work. Okay, let's take a look at a few more here. Okay, problem 4. Alright, so we've got C up here, A over here, side C down here, 26.7. This angle, well, if this is A, then this is angle A over here, that's 52 degrees. That must make this angle B, which is 70 degrees. And that means this is side B over here. Okay, so let's do the same setup. Angle A, angle B, angle C. So angle A is 52 degrees, angle B is 70 degrees. That makes 122, so 180 minus 122 should be 58 degrees. So now we've got all the angles. And our sides, let's see, we know that C is equal to 26.7, and then we'll find out approximate values for side A and side B. So let's go ahead and set this up. We've got 26.7 over the sine of 58 degrees, and that should be equal to B over sine 70. So B is going to be the sine of 70 times 26.7 over the sine of 58. Okay. So 26.7 divided by the sine of 58 times the sine of 70. And so we get B is going to be approximately 29.59. 29.59, and it's longer than C because angle B is bigger than angle C, so that works out. Okay, and then we'll do the same thing again, 26.7 over sine 58 equals A over the sine of 52 degrees. So A should be the sine of 52 times 26.7 over the sine of 58. 8, and then this time we want to multiply by sine of 52 degrees, and that says that A is going to be approximately 24.81. Okay, And so we see we've got the longest side across from the biggest angle, the shortest side across from the smallest angle. So that gives us some confidence that these answers are correct. And in terms of checking them, when I was making this section of the textbook, I went back and I double checked that all of these ratios turned out to be true. Once I finished solving the triangle, that's something you can do, is actually calculate this ratio, sine A divided by A. Let's see here. I'll do the opposite. The sides divided by the sines. So 24.81 divided by the sine of 52 degrees is about 31.48. And then if we do each of the other ones, 31.489 and sine of 58, 31.484. So these ratios do check out to these values, and so those answers should be correct. All right, so let's see. Look at the next one that has the diagram, problem 6, and then we'll look at a couple in the part where we don't have diagrams. Okay, problem 6. So we've got angle A here. We don't know how long that is, and we don't know what side A is. Side C is over here, which means this is angle C, and that's 40 degrees. That makes this angle B 37.5 degrees. And then over on this side, side B is going to be 17. Okay, so angle A, angle B, angle C. Let's see, angle B 37.5 degrees, angle C 40 degrees, and the one that we know, the side that we know is B, which is 17. So let's see, this is going to be 77.5. We do 180 minus 77.5, then that should be 102.5, right? 77.5, 10, 10, 8, yeah. 102.5. All right, so now here's our complete ratio. So we're going to set this up, 17 over the sine of 37.5 degrees equals A over the sine of 102.5 degrees. And, all right, so 17 divided by the sine of 37.5, and then multiplied by the sine of 102.5. And so that says that A should be approximately 27.26. Okay, and then for side B, B over, let's see here. Oh, that is B that we're using. C is the one we want. There we go. C over the sine of 40 degrees. Let's see, so we'll put in the 27.26 there. And then here, 17 divided by the sine of 37.5 multiplied by the sine of 40. And that says that C is going to be about 17.95. Okay, these sides are very close to each other. These angles are very close to each other. Here's the longest side. There's the biggest angle. That says we've got some confidence that we did this correctly. Okay, and again, you can calculate these ratios and make sure that they're all correct, that they're all equal to each other. Okay, so now let's look at the problems where we don't have a diagram. Okay, problem 8. So we've got angle B as being 70 degrees. That's going to look something like this. Angle C is 10 degrees. That's a very small angle, so that means it's either going to be coming down like this, if we want to put C up here. I'm going to put C over here and make this the 10-degree angle. That would put side C here, side B here, A, and A. Okay, let's see, and we've got angle B as being 70 degrees. And what are we missing? Side B is equal to 5. Okay, so there's one possible drawing for this triangle. Let's see, let's get this ready to make some answers. A, B, and C. So what do we know? Angle B is 70, angle C is 10 degrees. So that means angle A should be 100. Okay, because that'll make 180. We know that side B is 5, so then we can do 5 over the sine of 70 is A over the sine of 100. So 5 divided by the sine of 70 times the sine of 100. So A is going to be about 5.24. And then we'll do the same setup, 5 over sine 70 equals C over the sine of 10. 5 over sine 70 times the sine of 10. And that says that C is going to be approximately 0.92. Okay, so the longest side across from the biggest angle, shortest side across from the smallest angle. Looks like we're in pretty good shape. All right, let's look at a couple more of these. Now in section 4.2, we'll introduce a wrinkle that has to do with the law of sines. That makes things considerably more complicated, but we're going to save that for section 4.2. This first section is just to get us acquainted with the law of sines, working competently with it, and not worrying about any of these ambiguities that we'll get into in section 4.2. All right, let's see here. Problem 12. What do we have here? Angle B is 95 degrees. Okay. Angle A is 22 degrees, so that's going to be something like that. That one's 95. All right, so angle A, angle B, angle C. A is 22, B is 95. So let's see, that's going to make 117. So angle C should be 63 degrees. Okay, so that'll make 10, 18. Altogether, we get 180 degrees. And let's see, what's the side that we know of in this one? Number 12. Side A, 420. All right, B is over here. Let's see, so this is angle C, and that's side C over there. And we know that angle C is 63 degrees. Okay, so to find these other two sides, we'll set this up with side A over the sine of A, and then side B over the sine of 95 degrees. So then we'll calculate 420 divided by sine 22, and then multiply that by the sine of 95. B is 1,116.91. Okay. And then we'll set the same thing up for side C. C over the sine of 63 degrees. 420 sine 22, and and then multiplied by sine of 63 degrees. And that says that side C comes out to be 998.98. Okay, yeah, we've got the shortest side across from the smallest angle, longest side across from the biggest angle, so we look like we should be in good shape there. Okay, let's see here. All right. Well, let's do one more of these. Or maybe we'll do two more, because I want to do one where I kind of show how you don't have to necessarily draw a diagram, although I think that it can be helpful to figuring out what's going on. So if we do problem 14, we can just set it up without drawing an actual triangle. Let's see, angle A, 30 degrees, angle C, 65 degrees. So that makes 95. That means that we should have angle B as 85, right? There's 10, carry the 1, 12, and 6 is 18, so that makes 180 degrees. And what's the side that we have here? B is 10, okay? And so, again, we can set this up without an actual diagram. 10 over the sine of 85 degrees equals A over the sine of 30 degrees. So, 10 divided by the sine of 85 times the sine of 30. And so A is going to be about 5.02. And let's see what else. We're looking for C over the sine of 65 degrees. So 10 divided by sine 85 times the sine of 65 degrees says that C is going to be approximately 9.10. Okay. Let's see here. 9.10. That one was 5.02. Does that match up? Do the angles match with the sides? Roughly. You know, that's all we can say about that way of checking our answers. If you really want to check the answers, make this calculation and show that these ratios are actually the same. Okay. Well, let's go ahead and do one more. I'll draw a diagram for this one. Problem 16. Let's see what we've got. B is 28 degrees. So there's a nice small angle for angle B. Angle C is 78 degrees. So that'll look something like that. And that one is 28 degrees. That's B. So that's side B. That's side C. That's got to be angle A, and that's side A. All right, so angle A, angle B, angle C. Let's see, C is 78 degrees, B is 28 degrees. This makes, what, 106, so that would make this 74 degrees. Yeah, okay, that makes 180. So, and what side do we have for problem 16? C is a length of 44. Okay. All right, so there we go. So that allows us to set up our complete ratio here. 44 over the sine of 78 degrees should be the same as A over the sine of 74 degrees. So 44 divided by the sine of 78 and then multiplied by the sine of 74 says that A is going to be approximately 43.24. Okay, and then we'll do the same thing to find side B over the sine of 28 degrees. 44 divided by the sine of 78 multiplied by the sine of 28 says B should be about 21.19. Okay, so we've got the longest side across from the biggest angle. These angles are almost the same and their sides match up pretty well. Here's the smallest angle, there's the shortest side. Okay, so I think that's a good introduction to the law of sines. Section 4.1, we looked a little bit about how, talked a little bit about how to use it, where it comes from, why it's true, and then like I said, in section 4.2, we'll talk about some of the ambiguities that arise in trying to use the law of sines, and what we can do about that. And then in section 4.3, we'll talk about the law of cosines. As always, if you have any questions, please let me know. Thanks.